Slant asymptotes is part of section 3.5. You will know if you have a slant asymptote if the top leading variable is larger than the bottom one. So for instance here we have the exponent 2 is larger than the exponent of 1. So then how to find slant asymptotes when we have this part is we do division. So you want to put the x2 on this side, and then inside the brackets you do the x squared minus 5x minus 6. And then we do regular division. So we want to find x squared. So what times what will give x squared? What times x will give x squared? And we know that's an x, so we put x squared. And then negative 2 times x equals 2. So then after that you want to put a minus sign and then be the opposite of everything. So if this is positive x squared, it becomes a negative. And then this was negative 2x, so it becomes a positive. So we have negative, so then those cancel because that's a negative and that's a positive. Then we have negative 3x minus 6, because you want to always bring down the 6, or the next number. So then how to find negative 3? So then we want to find the negative 3. So then what times x will give you negative 3? And that's a negative 3. So negative 3 times x equals negative 3. And then negative 3 times negative 2 equals a positive 6. Oops. Oh, it is positive. Okay, so then we want to do that again by distributing, so it's opposite. So that was negative, because a negative 3 times x equals a negative 3x, so then it's positive now. And then this is positive, so it becomes negative now, and that becomes a negative 12. And our remainder doesn't matter, so then we know the slant is x minus 3. So then the next one we see is x squared plus 5x over x minus 1. And we know by looking at the variable, which is larger, and 2 is larger than 1. So again, we want to do the division. So then on this, we put that there, x minus 1, and then x squared plus 5x plus 6, so that goes inside the box. And then what times x will give x squared, and that's x squared, I mean. So then we have to distribute over here, so then x times negative 1 equals a negative x. So then we want to do a minus sign, and then we would do opposite. So that was positive, so it becomes negative. And that was negative, so now it becomes positive. And those cancel out, and then you get 6x. And then you always bring down the next number. So now we want to find 6x plus 6. So what times x will give us 6x? And that is a 6. So 6 times x equals 6x. And then 6 times negative 1 equals negative 6. So then again we have to do the subtraction, and we want to do opposite. So this was positive, so now it becomes a negative, and these can cancel out. And then we have 6, and then since we distributed that, a negative times a negative is a positive. So, but it is positive, so then 12. But the remainder doesn't matter, and the slant asymptote is x plus 6. And then the last one, f of x equals negative x cubed plus 3x squared minus x plus 1 over x squared plus 1. And we want to look at the variable again, and which one has the top number. So 3 is, so then we know we have a slant asymptote. So we want to move that into the bar, and then that into the bracket. So then what times x squared will give us a negative x cubed, and that's negative x. So then that would be a negative x cubed, and then we want to multiply that into the 1, and that would give us a negative x, but we don't want to put that there because we need to find that, so we want to move that down, and those cancel and that cancels, so perfect. So all we have to move down is the 1. So we want to find 3x squared. Since we have an x squared here, we need to find what would we do to multiply that to get us 3x squared, and that would be a 3. So then 3x squared plus, and then we multiply that in there, and that would be a 3, a positive 3. So then we want to distribute this And since this was positive, it becomes negative because of the subtraction sign, so those cancel. And then we have plus 1 minus 3 equals negative 2, but the remainder doesn't matter. So the slant asymptote is negative x plus 3.